In this video, we'll talk about Captchas, what it is and why it's put in place, and some of the approaches addressing Captcha challenges in your automation. We will then close with a demonstration showing an example. So, let's begin. By now, we all have seen it. That little button on websites saying, "I'm not a robot," trying to validate if you're a human, asking you to choose pictures that show traffic lights, crosswalks, or storefronts in an image grid. Those are called CAPTCHAs, or completely automated public Turing tests to tell computers and humans apart. And they are put in place by application owners for one reason: to prevent abuse. Easily accessible for humans and hard for robots to pass, and easy for a tester machine to create and grade are the three main attributes Captcha has to satisfy. Most Captcha techniques rely on the ability to identify and figure out visual, audio, and text cues that would be extremely challenging to imitate in digital workers. From simple match, math word-based problems, social media signing and sliders, picture identification, no captcha, reCAPTCHA, mouse movement tracking, biometrics, just to name a few. This is an ever-changing field, and CAPTCHAs are hard to keep up with these days. Here's a more difficult example of a CAPTCHA challenge showing a technique Amazon has filed for patent in 2017. Based on the first image, you must select the natural sequence of events from the choices presented to you, which in a way tests your understanding of Newtonian physics, something that would be very difficult for a computer to guess based simply on computer vision. But before I continue, here's an important disclaimer. Captcha is intended to stop automations, and companies adopting it to limit automated access usually carry a disclaimer with legal implications. Consider other methods to accomplish the task, such as the use of an API, an EDI, human-in-the-loop techniques, or other mechanisms that the application owner may have put in place. Prism does not endorse any captcha resolution platform or encourage captcha breaking without explicit permission from the application owner. And these examples demonstrated in this presentation are for illustration and educational purposes only. Now that we understand that, let's look at some approaches. First, as mentioned, avoid captcha breaking by using other methods, such as the use of a RESTful API. In Prism, it's very easy to invoke web services and APIs in your automation flow. Typically, in a modern application, an API is made available to enable automated processes to perform operations without having to interact with the front-end interfaces. A second option is to use a human-in-the-loop approach, where a digital worker collaborates with a human in the step that requires a captcha resolution. That is, the process flow execution is diverted to a human to answer the CAPTCHA challenge, and control is passed back to the digital worker to proceed. You can implement this in your automation design and use interfaces such as email, messaging systems, or a more robust collaboration framework, such as the Prism Interact, to leverage this approach. The third option is to use artificial intelligence frameworks. While you may be tempted to implement your own machine learning or OCR engine, it is a very cumbersome task to train and fine-tune models for a task that is always evolving, like we discussed earlier in this presentation. The fourth option seems more reasonable, which may leverage a combination of the techniques above mentioned, but performed by a third-party entity, where companies specialized in captcha resolution services start with AI and machine learning models of their own and may leverage internally a human-in-the-loop option when AI is not enough. This typically happens transparently, and your digital worker interacts with these services with a simple API invocation to submit the challenge and to consume the response. It is usually very fast, reliable, and an affordable way to address the CAPTCHA challenge. Let's look at an example. Here, The application consists of a login form screen, and the digital worker is presented with the Captcha challenge. We will save the image into a file and submit it for resolution to a third-party service. In this demonstration, I'm submitting the image capture using a form shown in the bottom of the page, but typically you would want to use an API to send the image. You will notice that once submitted, the third-party service returns a ticket stub. This ticket, or case number, is used to check if a response is already available. The digital worker submits the ticket number by way of an API invocation and receives back the response in a text format, which in turn is applied to the text field in the form to overcome the challenge. Let's watch these steps being executed. Although this is not necessary at the end of the execution, I send an email with the picture and with the actual resolution that was sent back into the process just for confirmation. This concludes our demonstration. Thanks for watching.